I'm in a bit of a different location today, but pretty chilly out here tonight, and I don't know if you can see snow all around, and it is currently snowing. I'm not sure how well that shows up on the camera, but it's snowing pretty heavy. Hi, I'm the Moss Man, and in today's video, we're talking about how my plants are doing in these winter conditions. Basically, I'm gonna go and look around at the plants that are in my house right now. And I'm going to explain why they are the way they are and the things that you can probably do to make sure your plants are better taken care of for the winter. When talking about the plants in my household, I usually divide them into two kind of microbiomes, two different environments. I have the plants downstairs, which I would call the hot zone, and the plants here are very few. I have a couple pothos, a jade plant, and there may be an aloe down there as well. These plants are relatively resistant to low humidity. They're fine to have there. They're also not entirely my plants, so I don't have full say over where they are or anything like that. But second zone is my room, which I would call the cold zone. The reason being is there is no heating in my room, and unfortunately, for most of the winter, it stays between 5 to 10 degrees Celsius, and whatever that is in Fahrenheit will be on the screen. Now, this is most of my plants because this is where I have dominion. These are the plants that I have the most control over. The moisture level is higher here because there's no artificial heating that's sucking away the moisture in the air. So the plants in my room around winter, to some degree, go dormant. They have the amount of light that they need still, supplied by my artificial light sources, which is one issue with winter, is the less light. But since it's so cold, they are still growing significantly slower. Now, of course, there's a few obvious issues with trying to grow your plants in winter, with the biggest one being light. Not many plant owners have an artificial light source designed for growing. Obviously, you have the ones in your household designed for you, the person living there. This, depending on the plants you're growing, is not enough. The best case scenario for anyone who's not changing the biome of their house to better fit the plants that they're growing, the best case scenario is your plants go dormant and they just grow extremely slowly or not at all for the winter season, and then start growing like crazy again in the spring. Let's get into some Mossman biochemistry. Woohoo! Basically, we have two opposing sets of reactions. In animal cells, you may have heard that the mitochondria is the powerhouse of the cell, the classic thing that everybody remembers from school. So, and what happens slightly more specifically is the inside the mitochondria, glucose and oxygen are broken down into water, CO2, and there is a energy. The main purpose of that reaction is to get that energy in the form of ATP, and this is the aforementioned power that the powerhouse of the cell is producing. Of course, nothing is ever as simple as it seems. There's always some way to dig deeper. What's actually happening here is the glucose is broken down into smaller, more manageable sugars. Those sugars are taken through a cycle where electrons are cleaved off of them. And then those electrons are used to power a piece of cellular machinery that produces ATP, which is the energy that we use. All right. That is the reverse reaction of photosynthesis. So if you look at these two reactions, you'll see that cellular respiration is sugar and oxygen being broken down to release heat and then create CO2 and water as a byproduct. And you'll see that photosynthesis is the exact opposite. You take sunlight, which is the energy coming back in, CO2 and water, and you turn it into oxygen and a usable sugar. And again, this cycle is a little more complicated than it seems. What happens in this cycle is the system of photosynthesis that turns this energy and these products into glucose is a couple of cycles that happen in unison. They have the light reactions and the dark reactions. And the product of the light reactions, or the light section of the cycle, is it releases oxygen, and it releases a couple important products for the dark reactions. It takes CO2 and it takes the byproducts from the light reactions other than oxygen, and it uses them with certain enzymes and stuff to eventually turn smaller sugars and other bits and pieces into glucose. That's how the plant meaningfully builds sugar. So within this Calvin cycle, the first enzyme, and if you don't know what an enzyme is, basically these little biological bits inside your body go, "Hey reaction, I have a nice cozy place for you to happen. Come in and happen." And then those reactions happen at rates that mean we can stay alive. So this enzyme, this thing that makes reactions happen faster, is important for helping turn CO2 into glucose in the end. This enzyme called Rubisco, which stands for, oh boy, I do not remember. Ribulose or ribulose biphosphate carboxylase oxygenase. So basically, Rubisco is important for beginning the transition of CO2 into sugar, except for it's super inefficient, it's bad at its job. Sorry, Rubisco. We are proud of you. Keep it up. And plants compensate by having a lot of it. And one of the problems with Rubisco is that sometimes, because CO2 and oxygen have similar enough shapes that Rubisco will bind to an oxygen instead of a CO2, it will create the wrong thing. It'll use oxygen instead of CO2 to try and create the thing, and then the plant has to go through a costly process to try and turn that back into the original product and use them again. The hotter it gets and the more your plant tries to reserve water, it has to either dehydrate or starve. You can worsen this effect by increasing the airflow. So like having a heat vent right beside your plant pushes that hot air constantly past your plant, constantly pulling the moisture out of the air around your plant and further dehydrating. Obviously, not all plants have this problem. For example, you have cactuses. And there are ways to combat this inefficiency, the inefficiency of Rubisco. C4 plants and other such things. I don't know how long this section is, but that is biochemistry with Mossman. The amount that your plant is likely to get dehydrated by having dry air caused by central heating is the shininess of the plant and the thickness of like the leaves. You'll notice that, for example, my maidenhair fern has a very thin and fragile leaf structure, whereas things like this coffee plant or this philodendron or the pothos will have a thicker and shinier leaf structure. This is caused by the plant cuticle, which is made of waxes, and a thicker plant cuticle allows for better water retention, whereas a thinner cuticle hasn't evolved in plants that are more likely to have higher moisture levels year-round. That's another thing to consider, and that's another thing you can look for in the plants that you are looking to keep in low moisture environments. Alright, thank you for watching. If you liked, make sure to leave a like and subscribe. And the channel at the time of recording is approaching 500 subscribers. So this video will be posted before the 500 subscriber Q&A. This is likely your last chance to either leave a comment on this video with the hashtag Q&A or a comment under the Q&A post on the Mossman Instagram right here with a question that you would like me to answer in my Q&A video. I'd like to thank Dylan and Elijah for the music, and I hope you have a wonderful winter.